What is the limit as x approaches 0 from the positive side of x ln of x? As x approaches 0 from the positive side, the x term approaches 0, while ln of x approaches negative infinity, so we have an indeterminate 0 times infinity case. We are only approaching this from the positive side since the logarithmic function is not defined for negative values in the domain, at least when we stay within the real numbers. I would like to use L'Hopital's rule to deal with the indeterminate case, but we would need a fraction to do this, and the expression we have right now is not in the form of a fraction. So here's what I'm going to do. Why don't we just move the x term into the denominator and rewrite this as the limit as x approaches 0 from the positive side of ln of x divided by x raised to the power of negative 1. Instead of multiplying ln of x by x, we can divide it by x to the power of negative 1, which is equivalent, except the expression is also in the form of a fraction, which allows us to use L'Hopital's rule. Recall that L'Hopital's rule states that if we have the limit of a fraction and we have an indeterminate case, we can take the derivative of the numerator and the derivative of the denominator, and the limit of the new expression will still be the same limit. In the new expression, as x approaches 0 from the positive side, ln of x approaches negative infinity, and x to the negative 1 approaches infinity. Therefore, we have a negative infinity over infinity indeterminate case, which means we can use L'Hopital's rule. If we take the derivative of ln of x, we get 1 over x, which is a standard derivative, and if we take the derivative of x to the negative 1 in the denominator, we get negative x to the negative 2 by using the power rule. Therefore, we can rewrite this as the limit as x approaches 0 from the positive side of 1 over x divided by negative x to the negative 2. We can simplify this expression by multiplying both the numerator and denominator by x squared, and the fraction becomes x over negative 1. This further simplifies to the limit as x approaches 0 from the positive side of negative x, which equals 0. So we can conclude that the limit as x approaches 0 from the positive side of x ln of x is equal to 0.